Hi and welcome to today's session on pie charts. So what does a pie chart look like? It looks exactly the way that it sounds. It is pretty much a pie shape where pieces are cut out of it. It's split into different sectors. So an example of the pie chart here, we've got an example just here. And a lot of my students say, oh, it looks a tiny bit like Pac-Man, hence why I've used this as an example. Pie charts compare proportions. That's all that they compare unless we've got any data in there. Anytime that we're creating a pie chart, we need to make sure that we've got a title. We need to have labels or a key so we know what the different sides represent. And the pie chart's got to be split into sectors. So a key bit of information is that if we've got no data on there, we can only compare the proportionality. Just literally compare the size of the different sectors. And those of you who may remember sectors, here we've got our diagram of the circle, which is labelled, and the sector is literally created by two radii going from the centre to the circumference, creating this sector just inside. It's the area inside. So a pie chart's a nice way of actually being able to display, but also compare data. So if we wanted to manipulate any data, it's also a good way of showing that, because if it's only showing proportions or percentages, you're not actually having to show the raw data. So as an example, I've got two pie charts comparing beer sales in the UK and in the US. Red represents Carling, yellow represents Miller's Light, the orange represents Budweiser, and the blue represents Stella. Now, do we think that the USA sell more Stella than the UK? Because if we was to look at our Stella, which is the blue area, the USA sector is a lot bigger than the sector for the UK. So a lot of my learners believe that yes, the USA must sell more than what the UK. But we can only state that the USA sells more proportionally than the UK, because we've got no actual raw data to deal with. We've got no numbers. If we had numbers in total or a number within one of the sectors or in all the sectors, we could actually compare them numerically against each other. So anytime that we are looking at this, we just got to bear this in mind, that we can only state differences in proportions or the percentages until we've got a bit of data to play with. So how do we draw a pie chart? So what we actually need is this calculation just here. So we've got our degrees of our data equals the frequency divided by the sum of frequencies. So one of our frequencies with one of our totals divided by the sum of our totals, and then multiply that by 360, because the 360 degrees within a circle. So leading on from that, anytime we're creating a pie chart, there should be, all the angles should add up to 360. There should be no gaps. All angles should be rounded to the nearest degree, which means that some angles might be just slightly overlapped. We've just got to use our best judgment for those. And each section should be labelled with or should have a key. So an example, degrees for our data, we've got 1 for our total of frequency, dividing that by 10, which is our total, timesing that by 100. So our angle to be measured for drawing this will be 36 degrees for this one category. So let's see this in action. So here we've got methods of transport for 20 students. If they got to college, we've got walk, bus, bike, car, and of course our total. 2 in our frequency, which means 2 people walked, 10 took the bus, and we're going to be using our formula. So 2, which is our frequency, divide that by 20, which is our total, times by 360, gives me 36 degrees. 10 divided by 20, that's 180, 18 degrees and 126 degrees. And now I could actually use those degrees to draw my pie chart. So I've got these just listed just here, just to remind ourselves. So first thing that we need is a circle. So putting our compass into a piece of paper and drawing a circle if it's not already given, and making sure that we're making a dot at the very centre point where we put our compass in. Next thing, we need a line. Most people draw it vertically going up, but it doesn't matter where you draw it. draw a line going from the centre to the circumference, so drawing a radius, because this is going to be our starting point to measure from. So first of all, we need our protractor to measure, and we're going to mark our first one, which is 36 degrees, marking that, taking the protractor away and drawing a line straight down. So now this is our first section. This is going to be walk, this is 36 degrees, but this line that we've just drawn, this is now going to be our next line that we are going to measure from. So setting up our compass, I'm going to measure 180 degrees and then drawing a line going straight from there. And this area has become bus. So I'm just going to continue repeating that until they're all done. And we don't have to do our very last section because we've automatically ended up with 126 degrees on there. We need our label showing what it actually represents. But this is not done yet because at this moment we've got different sectors, different sizes, but we don't know what they represent. So we could represent these by literally simply writing on the inside of each one what they represent. And that is a finished pie chart. But rather than doing that, we could also use colour coding with a key. So my key, I've got my blue section, which is my walk, my green section, which is bus, and I've got my orange section, which is car, and my purple section, which is bike. So using colour coding on my key, I've also represented a pie chart. So bear in mind that pie charts represent proportional percentages. We can use this information to interpret or analyse pie charts. So here I've got a pie chart with degrees in there for the different sections, similar to what we've already been looking at. And we're going to be using this to interpret the information on there. So we can see that most students travel by bus, because half of the students travel by bus, and the least amount of students ride a bike to college. Now, with more information, we could actually interpret this more by finding out numerical details for each one, which we're actually going to be looking at now. So if we was told that 20 people were asked, using this information here, we are going to be using this formula. So frequency equals degrees of data, divide that by 360, multiplied by the total number, our sum of frequencies. So our first one, 36 degrees for walk, divide that by 360, times that by 20, gives me 2. So 2 people out of the 20 said that they walked. And then carrying this on, I get my full amount, and I can check all these because if I add all these together, they should equal 20. We could be given the frequency of just one of the categories. So in this case, I've been told that 2 people walk, in which case I can use this to actually calculate the other frequencies within my data. So sum of the frequencies is going to equal my frequency given, divide that by my degrees of data, times that by 360. So this means that 20 people were asked all in all. 2 divided by 36 times by 360 equals 20. And again, I can use that information to work out all of the missing values like you just saw. We could be working in percentages rather than degrees, and this is the exact same except you are replacing your degrees, your 360 with 100 because you got 100% in total. And it is the exact same process as what we've gone through before, except replacing the 360 with 100. And again, we can do the exact same for working out if we're given one of the frequencies for the categories, and then using that to calculate all the others. If you like what you see, please subscribe. Thank you very much for watching.